All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 114 is on the screen. Get started, please. Copy and go. All right, for the sake of time, let's see what we got. Number 1, it says graph f of x equals 1 over x. So, first thing you should have done is identify what? The VA, which is 0, and the HA, bless you, which is also 0. So y at 0, x at 0. Using your table, you should have gotten your graph here and here. Hands if you got something like that. Okay, good. Next, number 2, graph f of x equals x squared. Here it goes. There it is. Next, rewrite this. Remember, there's an invisible 1. This becomes 1/4, so g of x equals 1/4 times f of x minus 1 squared plus 2. So that means we're going to move this one to the right and 2 up, or my new vertex at 1, 2. 1, 2. However, before I move it, look up to the screen. Tell your neighbor what this does to the original function. What does that do? Then Brandon's going to enlighten us. What does that fraction do, Brandon Darty? It shrinks it. That is correct. So it's going to bring it down like this. So now that we shrunk it, we move the vertex 1 to the right and 2 up. So that shrunk function is right there. Number 3, A. What'd you get for 3A? Brandon, pass someone. Anthony D. One over 8 to the 10th power. That is correct. 1B, Anthony D. 1, because any number to the 0 exponent is 1. How about 3C? What'd you get for 3C? X to the 9 over 1, or x to the 9th. That is correct. Number 4, if x to the 3rd times x to the 5th is this, x to the 3 plus 5, then what was this before it became 9 to the power of x plus -2? Tell your neighbor, and then Anthony D is going to pass it to someone. Pass someone, Anthony D. Who? Selena. What'd you get? What was this before it became that? That is correct. 9 to the x times 9 to the power -2. Now, I'm going to add one more step here. Let me zoom in. Look up. Let me mute the tunes. Question. Could we have a negative exponent? Therefore, 9x goes here. Where shall I put this? Tell your neighbor, where shall I put that to not have a negative exponent? looks like Bree's got it. Very good, Bree. Meadles got it. Very good, Meadles. Well, let's go with Selena. Pass someone, Selena. Where does that go, Courtney Jean? That is correct. It goes to the denominator, and it changes to a positive, 9 to the positive 2 exponent. However, can we still simplify? Yes. 9 to the x. What is 9 squared? 81. Woo-wee. Let's go. And last but not least, circle. All right. Let's see. Tell your neighbor the first step. Then Jacob's going to enlighten us. What do I do there? Tell your neighbor. Jacob, go. Oh, you're passing it to Brandon? All right. Brandon, pass it back to Jacob. Yeah. Oh, Jacob squared. There you go. Oh, my goodness. No more passes. No more passes. Anthony, go. Let's go from the corner. That is correct. Combine all the x's together. We got x squared plus 8x, empty space, plus all the y's. Y squared minus 4y, empty space, and all that equal to 5. Complete the square. What do I do? Anthony E., pass someone. What do I do, Anthony D? 8 over 2 squared to both sides. And negative 4 over 2 squared to both sides. That is correct. Plus negative 4 over 2 squared to both sides. So we end up with x squared plus 8x plus 16 plus y squared minus 4y plus 4 equals 5 plus 16 plus 4. Let's simplify this side. That's 25. And I'll factor this might as well here. Square root of the first, square root of the last, sine of the middle, squared, plus square root of the first, square root of the last, sine of the middle, squared. All right? So with that said, we need a center and a radius. Tell your neighbor the center and the radius for this standard form equation. What is our center and what is our radius? Center. Let's see, how about Noah? Center. Negative 4 and 2. Radius. 5. Yes, you take the square root of 25. All right, let's graph that. Let's see how this looks. Make some space. All right, bless you. We got negative 4, 1, 2, 3, 4, and positive 2. So our center is right there. And then radius, 5 steps in all directions. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 5. And it should look something like that. Okay? We good? All right. So, with that said, copy the agenda, please. Warm up number, 114. Warm up 114. 114, rational functions. Tonight's home plate, 8 rational functions graphs. Just to get us ready. Let's go. All right? All right, copy this code, Q9SIV, Q9SIV, and in there you should have access to the home plate. However, just in case the code doesn't work, get your phones out, take a picture of that. And also, by the way, you can also go to my YouTube channel and revisit the video lesson, right? Am I right? Am I right? And then just pause it when you get to the home plate and just copy from there. All right? So with that said, we are still graphing rational functions. Today we're going to revisit the home plate from the other day just to see how we did. However, I'm going to give you some time so you can set up 6 coordinate planes, please, from -10 to 10, 2 per page. I'll give you time for that. Those of you that are following on YouTube, same thing. Set up your coordinate plane, and we're going to be graphing. Go. Or should I say, those of you on YouTube following along, go get your flaming hot Cheetos and get ready. Bye. All right, here we go. Y'all ready? So, our objective for today is solving graph. Well, like I said, we're still graphing rational functions. So, remind your neighbor the definition of rational functions without looking at your notes. What is the definition of rational functions? Rational functions. What are rational functions, Emily P? Man, almost like if she was reading from the notes. Yes, an equation that contains one or more rational expression, which means, in other words, one or more what? Fractions. There it is. Non-examples, hashtags, we got that. From there, the steps that we follow for graphing. The first step is to identify the vertical and horizontal asymptotes. Do we know how to do that? Yes. We build an input-output table once we have our asymptotes, and then we graph the function. We went from our general transformation rule to this new one, and then we talked about asymptotes, what they were, invisible lines where the graph does not touch. And we said that H was our what? Vertical, and K was our what? Horizontal. So far so good, yes? And then we did some practice here, and your previous home plate were these 8. Is that correct? But me, I was expecting for you to do numbers 1 through 4, and maybe have, like, maybe you found a hurdle from 5 to 8 that you needed to get over. But we're going to do some of those in class, because I need to go over some of these. So I'm not going to go over number 1 or 2, since they're fairly straightforward, as well as number 3. But just to warm up, let's start with number 3, yes? So write this down. Number 3, at the top left, g of x equals 1 over x plus 1 plus 5. G of x equals 1 over x plus 1, and then next to the fraction plus 5. And this is just so we can get our muscle memory back on. And I know yesterday we took a little bit of time off because you guys were doing your state testing, but we're back. Back. So, step 1, we need our VA, x equals, and our HA, y equals. So, looking at this new function, tell your neighbor what your VA and your HA is. Then Maya is going to enlighten us. Tell your neighbor what your VA is and your HA is. VA, HA. I'm going to zoom in. All right, let's see. Bless you. Our VA, Maya, according to this, is -1, and our HA, 5. Let's go. Let's graph that. That's the first thing we do. So x at -1. -1 is right here. So we have a straight, invisible line going through that, like so. There it is. And then we need our HA at +5. +5 is right here. There it is. Okay. So step 1, you identify your HA, VA, and graph it. Step 2, we need an input-output table. We got X, G of X. So now we need a domain. We need X values. Remind your neighbor how to identify your X values. How to identify the X values. All right? How do we identify the X values, Kimberly? Yeah, 2 values for X from each side of the vertical asymptote. So let me highlight that for those that are following along. You highlight your asymptote. You focus your attention on the x-axis. You pick 2 values to the left and 2 values to the right. So I got -2 and -3. Over here we got 0 and 1. Is that correct? Yes? Here goes up. 0 and 1. So I'm going to use -3, -2. I am going to use -1, but I'm going to label it what? Tell your neighbor. Yeah, undefined, because that's our asymptote. Then 0, then 1. All right? So with that said, let's get some work in. Let me zoom in. So I'm going to write this right here. 1 over parentheses +1 +5. Let me zoom in. Whoa. Okay. -3. Here we go. Let's see. Help me out with this computation, Danny. What is -3 + 1? -2. Okay. So this becomes -2 on the denominator, 1 on the numerator, and at the end +5. So if you guys notice, this is a -1/2. This is a 5. I end up with what, Danny? 5 plus -1/2 is? Very good, 4.5. Write that in there, please. Let's do it again now for the next value. My next value is -2. All right? Here we go, Danny. -2 + 1. Okay, so -1. We got 1 and then +5. So, Danny, 1 over -1 is? +5? That is correct. Be nice. Oh, my God. You throwing you off? Okay. Oh, okay, Martin, let's go. 1 over Let's substitute 0. All right, help me out. Martin, what is 0 plus 1? So what is 1 over 1? That is correct. Man, let's go, Martin. And the last one, we substitute a 1 here. All right, Martin, here we go. 1 plus 1. So we end up with, let's go. Woo. Man, you're like Neo in the Matrix. Let's go. All right, let me zoom out. Let's graph that. I'm going to start with -3 and 4.5. -3, and we got 1, 2, 3, 4.5 is about right there. Next one, -2 and 4. -1, -2, 1, 2, 3, 4. So now we have our curve for this side. Then we go to these. 0, 6, 0, 6. 1, 5.5. 1, 5.5 is right here. Are we doing good? From 1 to 5, I'll come through where you with these. Yeah, we got this, right? So I just wanted to go over this one so that we can see the process, make sure we got it. So let's go to the next coordinate plane. And let's do, let me see. Yeah, let's do this one. Copy this one, example number 4. G of x equals 1 over 3x plus 6 plus 6. Copy that. All right, get us started, Anthony E. What do I do first? The what, I'm sorry? What? We start with step 1, which is our VA, x equals HAY equals. So, the VA, how do we find VA? Tell your neighbor, and then Brandon's going to enlighten us. How do we find our VA? All right, let's see. How do I find my VA now that we have a coefficient here of x? What do I do, Brandon Felix? -2. Oh, sorry. So for our VA, it's -2. Okay. Now, for those of you that forgot, let me zoom in. How did Brandon Felix get -2? Well, he said, I set this up equal to 0, -6 minus 6, 3x equals -6, divide by 3, x equals -2. That's how we get our VA. And of course, our HA, straightforward from here, that is 6. All right, let's graph that. Let me zoom out. -2 of x is right here. Then we got +6 of y, which is right there. All right. So step 1's done. We need a table. X, G of x. Once again, remind your neighbor how to get the domain or the x values and write them in there. All right, how do we get our x values, Jacob squared? Two to the left and two to the right of the vertical asymptote. That is correct, man. I should give him extra credit. So highlight your vertical asymptote. Pick two values to the left, which are -4, -3. Two to the right, which is -1 and 0. So I'm going to use these five right here. -4, -3, -2, -1, and 0. And of course, our -2 is what? Our undefined. So, let's write this here next to the 4. We got 1/3 parentheses plus 6 plus 6. All right, let me zoom in. Here we go. -4. So, since Danny's pretty good at these, let's see. Help me out, Danny. What is 3 times -4? -12 plus 6, -6. So, we have 6 minus 1/6. For the sake of time, that leaves us with 5 and 5/6. Go to the next value. 1/3 parentheses plus 6 plus 6. And the next value is -3. All right, Danny. What is 3 minus 3? 3 times -3. -9 plus 6. -3. So, we have 6, take away 1/3. That leaves us with what? 5 and 2/3. That is correct. Woo-wee. Let's go, Martin. Next ones are yours. We got 1/3 parentheses plus 6 plus 6. Here we go. Martin, 3 times -1 plus 6. So this is 1/3 plus 6. Oh, whoa. What was that? Plus 6. That gives me very good, 6.3, or 6 1/3. And last but not least, 1/3 plus 6 plus 6. You substitute the 0. So this is 0, right? So this is 1/6 plus 6, which is 6 and... Very good. There it is. All right, let's graph that. Here we go. So, -4 and 5 5/6. -4, and then we got 1, 2, 3, 4, 5 5/6. That means it's almost all the way up there, but I'm going to place it right there. Next, -3 and 5 2/3. -3, and we got 1, 2, 3, 4, 5. 2/3 is about right there. Curve it. Next, -1 and 6.3. -1. We got 1, 2, 3, 4, 5, 6.3 is about right there. And 0 and 6 1/6. 0, 6 1/6, very close to the asymptote. From left to right. There you go. Let me pause this really quick. From 1 to 5, how comfortable are you with this so far? We got this. All right. VA x equals HA y equals. All right. Tell your neighbor your VA and your HA, and then Bailey's gonna enlighten us. What is your VA? What is your HA? Tell your neighbor, please. All right, Bailey, what is our x equals? 4, and our HA? -5. Hands, have you got that? That is correct. So we got x equals 4 is about right there. Let's get our asymptote, vertical asymptote going straight down. And our HA is at -5, which is down here. Dotted horizontal going through there. There it is. Next, x, g of x. Tell your neighbor the domain that we're going to use by looking at that. What is the domain that we're going to use? What is our domain? Tell your neighbor before Rebecca gives us the answer. Domain. All right, Rebecca. You said what? What's the first one? Let me zoom in case you don't see it. That is correct. 2, 3, 4, 5, and 6. And of course the 4 is our what? Undefined. There it is. All right, so I'm going to write 1 over parentheses -4 -5. However, look up. Don't forget the 2 that you're going to multiply that fraction by. So let me zoom in so you can see the work. Our first value, +2. So, here we go. 2 times, we have 1 in the numerator. Ryan, 2 minus 4. -2, then at the end -5. So watch. 2, you distribute to the numerator, that becomes what? 2 over -2 minus 5. Rylan, what is 2 over -2? -1 minus 5? Yeah, -6. Write that in there, please. Let's do it again. 2 times 1 over -4 minus 5. Next value, 3. So it's 2 times 1 over 3 minus 4 is -1 minus 5. So let's see. Look up. Distribute the 2 to the numerator. So what is 2 divided by -1? Riley. -2 minus 5? You said -2? Minus 5? -7. Very good. Go to the last 2 values. 2 times 1 over 5. Martin, let's see. 2 times 1 over 5 minus 4. 1. Distribute the 2 up here. So what is 2 divided by 1? Minus 5? -3. And last but not least, 2 times 1 over parentheses -4 minus 5. Let's see. Whoa. 2 times 1 6 minus 4 is 2. Distribute that here. 2 divided by 2 is 1 minus 5. That's negative 4. All right, let's graph that. I know the bell's about to ring, but bear with me. Here we go. 2, negative 6. 2, negative 6. 3, negative 7. Graph. 5, negative 3. And 6, negative 4. Graph. From 1 to 5, I'll come to worry with this. Yeah, we got this, right? Now, check this out. Look up. What if I gave you this? Look up with a negative here. Tell your neighbor what to do with that negative at the end. Yeah, you flip the function. Okay, we'll stop right there. Once again, make sure you do the practice tonight. I am picking up that tomorrow. Wait a minute. Isn't tomorrow Friday? Let's go. Let's go. No. Have a good one, guys. See you guys tomorrow. Bye. No, go right now. Yeah.